Previous year question. Test convergence of summation n equals 1 to infinity 1 by root n plus root of n plus 1. This question can also be asked as test the convergence of the series 1 by root 1 plus root 2 plus 1 by root 2 plus root 3 plus 1 by root 3 plus root 4 plus etc. Observe that here the terms are so related that whichever term appear in the first square root, the next term in the square root is obtained by just incrementing the previous number by 1. Here also you can see that 3 is obtained by incrementing 2 by 1. 4 equals 3 plus 1. So the general fashion of the series is that the nth term will look like un equals 1 by root n plus root of n plus 1. So if the question is asked in this format, which is summation n equals 1 to infinity un, or this format, the general term is the same, un equals 1 by root n plus root of n plus 1. Here, if we take out n common outside from inside the square root, we have when n is taken common outside from n plus 1, you have n into 1 plus 1 by n. When this n is taken outside the square root, it becomes root n. Since root n is common to this term and this term, once this n is taken outside the square root, you can take it outside common from the entire denominator. So you have the expression un equals 1 by root n into 1 plus root of 1 plus 1 by n in the denominator. Numerator is already 1. What we did is we just took outside n common from n plus 1. This n when taken common outside from inside the square root. This n when appears outside the square root, it becomes root n. Once it is taken outside square root, we have root n which is common to both terms of denominator. So it can be taken outside from the entire denominator. So the expression can be written as 1 by root n into 1 by 1 plus root of 1 plus 1 by n. Now we will have to select a series summation vn such that the nth term vn equals 1 by root n, so that it can be easily cancelled and we can apply the limit n tends to infinity for the ratio un by vn. So we will be selecting summation vn equals 1 by root n here. We have vn, the general term of summation vn equals 1 by root n. We know the behavior of summation vn equals summation 1 by root n. We have summation vn equals summation 1 by n raised to half. Whenever p is less than 1, the given series will be divergent as per p test. Therefore, summation vn equals summation 1 by root n will be a divergent series. We have taken vn equals 1 by root n, and when we consider the ratio un by vn, you can see that 1 by root n get cancelled from both the expressions un and vn. We are left out with limit n tends to infinity to be applied on 1 by 1 plus root of 1 plus 1 by n. When limit n tends to infinity is applied to 1 by n, we have limit n tends to infinity 1 by n equals 0. Therefore, the square root becomes root of 1 plus 0, and root of 1 plus 0 is root 1, and root 1 is 1 itself. Therefore, the answer for limit n tends to infinity un by vn equals 1 by 1 plus 1, which equals 1 by 2. 1 by 2 is non-zero value and it's finite. Therefore, the behavior of summation un and summation vn will be the same. Since we have observed that summation vn is divergent, the same behavior will be shown by summation un as well. Therefore, we will conclude that the given series summation un is divergent.